All right, my darlings, I want to do a little review here of lesson, I think it was 1.03, and the name of the lesson was Matter and Energy. So just a quick review. I'm going to go quickly, going to talk fast, go through the slides real fast here, pause if you need to take notes. Solids, liquids, and gases, those are the three states of matter that we are interested in chemistry. Just so you kind of commit this to memory, solids and liquids cannot be compressed because their particles are already really close together. They're touching, but gases can be compressed. Remember, those particles have a lot of space between them, so it's important for you to remember that gas particles can be compressed. We're going to do a whole unit on gases later in the semester, so it's important to kind of stick that in your brain, that there's a lot of space between those gas particles. Next up, we have what happens when matter changes state. Energy going into a system is called an endothermic process. That means energy is being absorbed by the system. If something goes from a solid to a liquid to a gas, it's got to heat up, and so energy has to enter the system. If we go in the opposite direction from a gas to a liquid to a solid, energy has to be removed from the system. Something gets colder because heat is removed, not because coldness is added. So when we go from gas, when a gas condenses into a liquid and then liquid freezes into a solid, heat energy has to be removed from the system, and that is called an exothermic process. Changing state is a physical change. So when a substance goes from being a solid to a liquid to a gas, that is not a chemical change. For example, if water goes from ice to liquid water to steam, it's still water. It's still H2O. It's just in a different physical state. So a physical change, like a change of state, right, does not alter the chemical composition of the substance. It is not a chemical change. Examples of physical changes, like I said, are changes of state. If something breaks, if you grind something, if you change its shape, if you bend it, if you tear it, you could tear a piece of paper, it's still paper, right? Now, if we're talking about altering the identity of the matter, that would be a chemical change. In other words, a chemical reaction has to occur. A chemical change or chemical reaction actually changes the composition of the matter and a new substance is formed. An example would be burning or cooking or rusting or oxidizing or tarnishing. Those are all chemical changes. So if I took some paper and tore it, or crumpled it or folded it, that would be a physical change. But if I set the paper on fire, that would be a chemical change. The paper is being changed into a new substance. I can't get the paper back, right? And so that would be a chemical change. Another example of a chemical change would be baking a cake or cooking something. If I take flour and sugar and water and eggs and chocolate and mix it up in a bowl, that's a physical mixture. But once I bake it in the oven and get a cake at the end, that's a chemical change. I can't get the eggs back. I can't get the sugar back. I can't get the flour back. So when you cook or bake something, that's a chemical change. You can't get back to the original ingredients. And again, of course, anytime there's a chemical change or a physical change, if energy is given off, it's considered an exothermic process. If energy is absorbed, it's considered an endothermic process.